Hello everyone. In this video we're going to look at lesson 3.3, which is solving systems by substitution. So it's a continuation of what we did yesterday. So this is part 2. So the steps for solving systems by substitution. These were in yesterday's video, so if you didn't get them yesterday, take a minute to pause the video and write these down. But these are the basic steps that we go through. Some special cases that we're going to see when we're solving systems of equation, and these are similar to the graphs that we looked at the other day. If all of our variables cancel out, we're either going to have no solution or infinitely many solutions. Okay, so this is just like going back to when we solved equations, and if all of my variables canceled out and I ended up with something like 2 is equal to 7, okay? Since this statement right here is not true, that means that we have no solution. Okay. Also, if I have another problem where all my variables cancel and I get something like 3 is equal to 3, since this is true, my solution, I will have infinitely many solutions. Okay, so, and this actually this is related to the graphs we looked at on Friday. If I were to graph this one right here, what we would actually see is 2 parallel lines that never cross each other. If I were to graph this one, what we would see is overlapping lines, which give us those infinitely many solutions that we're going to have here. So now let's take a look at some examples when we are solving by substitution. Okay, so these are a little bit different than yesterday. Yesterday we had an equation that already had either x or y by itself. Today we're going to have to take an extra step, and we're going to have to get the x or y value by itself. Okay, so just glancing at these two equations, the one that is going to be the easiest to isolate is this one right here. Okay, because it doesn't have a coefficient, and I'm able to get it by itself pretty easily. So if I look at that equation right there, all I have to do is move that 6x to the other side, which would be y is equal to 6x plus 2, okay? So now when I solve this equation and I get y is equal to 6x plus 2, again, what we're saying is that y is the same thing as 6x plus 2. So I am able to replace this y right here with 6x plus 2. Okay? I cannot put it into this bottom equation. If I do that, so now that we have y by itself, we're able to substitute that 6x plus 2 for y. So if we do that, we'll have negative x minus parentheses 6x plus 2 is equal to negative 2. Okay, so now we just need to solve. So let's distribute this negative. So that would be negative x minus 6 minus 2 is equal to negative 2. That's a 6x there. So now we have negative 7x minus 2 is equal to negative 2. If I add 2 to both sides, I now have negative 7x is equal to 0. So x is 0. Okay, so now we're going to go back and solve for y, and we can use that new equation that we created, y is equal to 6x plus 2. So if I sub 0 in for x, I get y is 6 times 0 plus 2. So y is 2. So there is our solution. We have x is 0 and y is 2. Okay, so let's take a look at another one. So here we have the two equations, negative 2x minus 8y is equal to 5, and x plus 4y is equal to negative 6. So again, the bottom equation, that x right there, that's going to be the easiest one to isolate. So if I just subtract 4y from both sides, we get x is equal to negative 4y minus 6. Okay, so now we're going to go up to the top equation and substitute we're going to substitute this in the place of x right here. Okay, so that gives us negative 2 times negative 4y minus 6 minus 8y is equal to 5. Okay, so first thing we're going to do is distribute. So I have 8y plus 12 minus 8y is equal to 5. And notice we have these like terms here. Those actually cancel each other out. So our y is actually gone here, and I'm left with 12 is equal to 5. So this is one of our special cases, okay? So our variable has canceled out, and what we notice is that this is not true. And since that is not true, this system actually has no solution. So these two equations are never going to cross each other. If I was looking at a graph, I would have two parallel lines here. Okay, the next example, okay, again, solve these equations. So looking at these, this y right here, that's going to be the easiest one to isolate. If I just add 2x to the other side, that's going to give me y is equal to 2x minus 8. So now I can take this 2x minus 8 and we're going to replace y with it because it's the same thing as y. So we have 6x minus 3 times 2x minus 8 is equal to 24. Okay, so now get rid of your parentheses again. So 6x, distribute the negative 3, so that's negative 6x plus 24 is equal to 24. Okay, so these actually cancel out. So I end up with 24 is equal to 24. Okay, so again, our variables cancel out, but this time it is a true statement. So since we have a true statement, this system actually has infinitely many solutions. And if I were to look at a graph of this thing, these would be overlapping lines. And there's infinitely many points that are going to be a solution to both of these lines. Okay, so today let's work a little bit more on solving systems by substitution. Please let me know if you have any questions on it.